My name is David Golden. I'm with Ambient, and welcome to Global Solution for Healthier Air, which is our sixth Ambient Academy course to date. We have with us today Kevin Fahey from AtmosAir, and he's going to be giving this presentation for you. Before we get started, if you're not familiar with Ambient, we're a primarily Northeast-based HVAC collective. And then we do commercial, residential, and healthcare-based HVAC services. Before we get started, you can enable your camera and you can enable your microphone if you so choose, if you have any questions throughout the course of the presentation. And then just to make sure that when you join this call, that you're using your correct name, the same name that is on your Ambient Academy registration, just to make sure that afterwards we can make sure that your PDH certification is issued correctly. So without further ado, I'm going to pass it off to Kevin Fahey from AtmosAir. And Kevin, you can go ahead and share your screen whenever you're ready.
Okay, thanks, David. Let's see. So do you see a full screen or do you see a half screen right now?
Looks full screen, looks all set.
Okay, that's great. So as David said, my name's Kevin Fahey. I'm the Vice President of Sales with Clean Air Group. And today I'm going to cover a presentation on indoor air quality and the technology that we have available. So just okay, there we go. So just on the agenda, it's we're going to give you a real brief review of the company, AtmosAir, and then talk a little bit about the heightened awareness of IAQ in the marketplace. Talk about our technology, which is today we're going to focus on the bipolar ionization and some of the testing and validation that we've done with it. Some of the more recent activity with ASHRAE, including their standard 241, a few case stories, and then a couple of additional solutions in addition to bipolar ionization. And as David said, please ask some questions and make it as interactive as possible, and we can, and it'll make the presentation more educational. So just make sure that, so are you seeing these screens move along?
Yep, all set.
Okay. So just a little bit about AtmosAir. AtmosAir is the parent company is Clean Air Group, and Clean Air Group has two brands: the Atmos brand, which is a bipolar ionization technology through dielectric barrier discharge, and then the Bioclimatic, which has bipolar ionization through needlepoint technology. And we're not going to talk too much about that today, but also other solutions as far as filtration and custom air handlers that through the Bioclimatic brand. We're headquartered in Fairfield, Connecticut. The Atmos brand started in 2004. And we've brought this technology over from Europe and did a lot of different testing and created some changes to the technology. People say, bipolar ionization, emerging technology. Well, the company that we purchased this from was started in 1970 in Sweden. So, we don't consider it emerging, and we improved it. We've got 10 patents to show for that. We have offices in Arizona. We manufacture out of Delran, New Jersey. We also do contract manufacturing out in Arkansas and have offices in the Middle East, London, and over in the APAC regions, Shanghai. We literally cover every vertical of facilities between commercial workplace, which is the largest, sporting, hospitality, hospitals, education, etc. So there's really with this technology, there's two things that we try to do. We try to improve the indoor air quality, and if you look in the upper right, that's a sample of one of our devices. It looks like tubes on the top, and those are what are generating ions for air purification. And then we also want to monitor so that we can show that the air is actually being cleaned by the devices, and that's what you see in an example of in the lower right. But another thing that you can do when you're using an air cleaning strategy, and you may or may not have used this in the past, is AtmosAir will allow you to use the indoor air quality procedure and use an engineered approach versus the ventilation procedure, and you can reduce your outside air. And then with the agglomeration effect, you can actually reduce the MERV rating on your filters, which helps save energy, reduce operating cost, and is a more sustainable operation of your facilities. So the next several slides are just kind of why indoor air has gotten a lot more attention. Well, these are I'm not going to read these slides as we go along, but these are just stats from the EPA and the American Lung Association. The most important thing is we spend the majority of our time indoors, and it's one of the top 5 health threats in the U.S., the indoor air quality, and it's much worse, frankly, than outdoor air because of the contaminants that are associated with off-gassing of things in the indoor environment. There's been several surveys more recently, and there's been really a change in the mindset of people in the office market. And this was a survey of 2,500 people. It just expresses that people are concerned more about indoor air quality than they ever have. In fact, they expect the ownership and the companies that they work for to monitor the indoor air so they know it's healthy. And so that's at an 86% rate. So it's a lot more top of mind than it was. And I think the pandemic, I think we'll all agree, created a lot of this. I'm not sure if any of you saw this, but 2.5 weeks ago on 60 Minutes, they had a 20-minute segment on indoor air quality. And they interviewed Dr. Joe Allen from Harvard School of Public Health, and he just really covered the need for buildings to have better indoor air. And he's a huge proponent of filtration and outside air ventilation. But when they, as part of this segment, they interviewed the International Facilities Management Association, and 91% of the respondents in that from that survey said that they had implemented bipolar ionization as one of the ways to improve indoor air quality in facilities. This is some data from an engineering firm. It happens to be in Manhattan, a large engineering firm. During the June wildfire haze that we had, that was June 7th and 8th of this past summer. And they have on their floor an installation of bipolar ionization, and they're doing monitoring. And they also have MERV 15 filters as the base filtration for the building. So what they did is they had an industrial hygienist come and do samplings of the outdoor air quality at street level, and then did some readings for the air quality in a floor with MERV 15 filters, but no bipolar ionization. And then they did some in their office with the bipolar ionization. And it's a bit of an eye chart, but again, I'll send this presentation to David, who can send it out to the group so you can see some of these stats. But you'll see there's a significant increase, even with MERV 15 filters, adding bipolar ionization. As far as reducing particulates that were a result of the wildfires. Mentioned earlier about using, ASHRAE's 62.1 indoor air quality procedure or the IMC international code. Both of those allow you to provide an engineered approach to outdoor ventilation versus using the ventilation rate procedure. And if you do use 62.1, with our technology, we have certain testing that allows it to be used, and you can usually reduce your outdoor ventilation 50% from what it would be with the ventilation rate procedure. And if you do that, you can get a reduction in the tonnage of heating and cooling that you're going to require, save money on first cost. You can also reduce your ongoing expenditure because you're going to be conditioning less outside air. And that can, depending on the part of the country the facility is in, it can be anywhere from 20 to 40% reduction in expenditures. We usually see closer to 25% as an average. It also, by recycling cleaner air, you're going to have less frequent maintenance required in changing filters. And if it's a huge chiller plant, you'll be reducing your water consumption as well. So that's part of the ASHRAE 62.1. But to use that, you have to do all this mass balance analysis that's part of 62.1. So what we've done is we've come up with a spreadsheet calculator where if you enter the stats that you have for the ventilation rate procedure, the type of facility, the size of it, the occupancy, etc., and our spreadsheet will do the mass balance analysis for you and show you where you can reduce your outside air requirements with 62.1 versus using the ventilation rate procedure. Before I go on, any questions so far? Okay. So let's get into ionization, bipolar ionization specifically. What is it? Well, ions are nature's natural air cleaning process. They're prevalent outdoors, and they're the reason that the wildfire haze didn't continue for months at a time. They eventually gets cleaned by ions in the air. So what do? They help agglomerate particulates, and they help oxidize volatile organic compounds, and they can neutralize or sterilize microorganisms like bacteria and virus and mold. And if you are in a very pristine environment, let's say top of a mountain, you're going to get ion readings. They're measured in ions per cubic centimeter, and you're going to get readings in the 1,500 to literally 5,000 range. And we consider 800 to 1,500 fairly pristine environment if you're measuring ions in that level. But when you get into more urban environments, there's a lot more pollution, whether it's coming from facilities, exhaust, or it's coming from cars and the exhaust from them. There's a lot more pollution that ions have to deal with, so the counts are much less in an urban environment. And then you get inside of a building where you're bringing that outdoor air inside the building, and you have the off-gassing, and you have people in that building, and ion counts get much, much lower. So what we do is we help engineers design an equipment selection that will increase the ion levels to what you would find in a more pristine outdoor environment of 800 to 1,500 ions per cubic centimeter. So how does it work? This is considered an active air cleaning process. Active meaning we put these tubes on the supply side of an air system. They could go in the discharge plenum of an air handler. They could go in the main supply ducts before they branch. They're downstream of coils and filters, and so that they're the last thing before the air hits the ductwork and then gets into the occupied environments. And so what we want to do is we want to create these ions with the tubes and the supply air and saturate the occupied environments with these ions so that we're cleaning the contaminants in the space where they're created and generated, not waiting for contaminants to come to the air handler to be cleaned, which is required if you're just using filtration or using UV. The air is being cleaned once it gets to the air handler. So this makes for a more active approach to cleaning your air versus a passive approach of waiting to come to the air handler. And there's really, as far as bipolar ionization is concerned, there's two types of technology. As I mentioned earlier, I'm going to talk mainly about the dielectric barrier discharge. That's the AtmosAir product. Our bioclimatic product is a needlepoint product. The main difference is the electron volts that are required. The ionization energy to create an ion is much higher with a tube-based DBD than it is for a needlepoint. And why is that important? Well, because by creating this different, more powerful ion, it's going to last longer and up to 300 seconds to help saturate a space. Not only that, with DBD, you're creating ions in an alternating fashion, positive, negative. So you're going to get less pairing of ions in the ductwork before they get to the space. So both technologies will work from the standpoint of agglomerating particles and oxidizing VOCs, but there's something more special additionally that the dielectric barrier does that the needlepoint will not. And I'll get into that in a second. Here it is. So three things. Agglomeration is particles getting larger. They either fall out of the breathing space, and I'm talking about nanoparticles, particles that are less than 2.5 microns in size. These are the particles that will get into your lungs and get into your bloodstream and really are irritants for people who have allergies and asthma, things of that nature. So it agglomerates these particles, they fall out of the breathing zone, or they're more easily picked up by a filter. We have an ASHRAE did a study that showed the impact of the combination of MERV 13 filters with our technology and how it made it much more effective, and I'll show you that toward the end of the presentation. But so agglomeration is one of the features. Another is oxidation, and that's just taking volatile organic compounds and oxidizing them so they're broken down into their simplest form of CO2 and water vapor with no harmful byproducts as a result. And that's the inactivation of microorganisms. And that's something that the dielectric barrier technology can use that can do that the needlepoint can't. And why is that important? Well, needlepoint can agglomerate these viral particles, but they're still active, where this sterilizes them on contact. And how does it do that? Not to get too much into the chemistry, but it uses an electron volt energy of 12.6, and that allows it to ionize oxygen to create this stable superoxide anion, and then it also allows it to ionize ozone, so it doesn't create ozone, and it, as a result, complies with UL 2998, less than 5 parts per billion of ozone. So that's the main difference. As I mentioned earlier, they're produced in alternating fashion. It gets more ions into the space. So, and then the difference, as I mentioned, is the sterilization. And the way that does is it literally creates what's called a hydroxyl radical on the surface of of any sort of microorganism. Different from other technologies, there's other electronic air cleaning technologies that produce hydroxyls as a result of is what they're generating the hydroxyl, and the hydroxyl will last 1 to 2 seconds. So that if you're generating hydroxyl inside of an air handler, anything that comes through that air handler could get cleaned by the hydroxyl. But the difference with this technology is you're creating the hydroxyl on the actual surface of the microorganism. And that means you're just sending out negative oxygen molecules out into the space. And when they find a microorganism on the surface of that protein, they're going to grab a hydrogen off that. And that forms the hydroxyl right there. So that allows that hydroxyl to act on that particular microorganism, bacteria, virus, mold, whatever it be, and neutralize it. So if it does get caught in a filter, or it gets into somebody's lungs, it cannot infect because it can no longer replicate at that point in time. So that's a little bit on how the technology works. Any questions? Okay. So now let's just show you some examples of the actual equipment that we put in. The for large air handlers, we use what we call a 500 series. That one on the top right is 8 tubes that are 22 inches long. That device on the bottom is 29 inches by 11 wide, and top of the tubes to the base is about 11 inches as well. The thing that's nice about that can manage air supply of 15,000 CFMs, which would usually in a typical, like an office environment, that would be enough for 15,000 square feet of space. And it only draws a quarter of an amp of power. So you could literally power this thing off the, light switch, or lighting in an air handler, or in the room near where the mechanical room is. It draws not only a quarter of an amp, but the power consumption is 49 watts. So it doesn't use more power than an incandescent light bulb. So, and the third thing that's nice is there's relatively no pressure drop. Something like this is just under 2/10 of an inch pressure drop with because you're not filling the entire duct or the entire, not like a filter where all the air has to pass through it. Just a portion of the air passes over these tubes. And then we scale down to something that would be for a hotel room or a conference room, and I'll show you that in a minute. But so the next size would be 5 tubes that are 22 inches, and that'd be good for about 10,000 square feet. Or then we have another device with 5 tubes that are 14 inches that could handle up to about 8,000 square feet. And then for smaller systems, 5-ton and 10-ton systems, we have these single tubes or double tube devices. And again, the amperage draw and the wattage used is next to nothing for both of these devices. And then we have more compact ones for fan coils, water source heat pumps, PTACs, that go either inside the unit or inside of a small duct. And these, again, this is what would be more prevalent. The one in the FC400 that you see would be more prevalent in a hotel room size facility, or if you're conditioning with many fan coil units in a space. So an example of what these might look like installed on the left-hand side, that's literally 100,000 CFM air handler discharge plenum. where we rack up seven of those of the largest units with the 8 tubes. The one in the middle is just an example of something that requires 16 tubes. And there's some duct mounted, so the tubes are on the inside and the electronics are on the outside. And then you see smaller examples of just single tube units, how they'd be installed in a ductwork or in a unit ventilator. So before I go on to monitoring, any questions? Okay, as I mentioned earlier, we feel it's very important. Ions are nothing more than charged oxygen molecules, and very important to see that they're working. And it's really hard to tell. I mean, if there's an odor in a facility, and it'll clean that odor, it's working. If it was, days like we had with the wildfire haze, and you have a heavy dose of particulates in the air, you'll know it's working. But, in a typical day, it's hard to tell unless you're monitoring the air quality. So we have a couple of different ones. We have wall-mounted units, which you see on the AtmosAir and the AtmosAir Mini. And then we have one that's called AtmosSmart that is actually installed in the return duct to measure the air quality coming out of a space. And I'll talk a little bit about each of these. So the AtmosAir it's got a display screen. It measures 5 parameters of air quality: carbon dioxide, particulates that are 2.5 microns and smaller, volatile organic compounds, temperature, and relative humidity. So it measures them real time, and every minute it's sending information. You can get this information sent to your BMS or BAS through BACnet IP, or you can send it to the cloud, and there's a dashboard that you get with the sensor that will show in real time what the air quality is, and it also trends the air quality. So as you see on the left side of that, you see all those little charts. That's just could be a week's worth of information, and then also you can get it. So there's an app on your phone, and you can, in the lower portion, that's just an example of a phone app showing the air quality. So people don't have to be in the facility to see it. They can be at a computer, they can see it on their phone, or you can see it actually on the display. And the Mini is just the exact same sensor without a display. I mean, there are people who want to be transparent with the indoor air quality, and there's people who don't want to be transparent, and because it may have too many questions as a result. So this is just the same sensor technology. Again, it goes on a wall or in a ceiling, and will measure the 5 parameters of air quality. It also has the opportunity to switch out to add a ozone sensor in this one, which the display didn't, if that's a concern for facilities. And then the third sensor type is, as I mentioned, it's in duct. We put it in the return duct, generally just before the air handler, sometimes even in the mixing plenum of an air handler. So it's sourcing the air coming out of the space, and this also is connected with the ion generators. So based on the air quality that's coming out of the space, it can modulate and control the ions being generated into the space. So this is, if you have heavy contaminant levels, you'll generate more ions, and if it's not so bad, then you'll generate less ions. So this is something that is integrated with the ion generators. The ones on the wall are just independent readers of this, and this one will actually not only read the IAQ data, but it will control the ions as a result of what the air quality is. The other thing that this has, you can either send it to the BMS as you could the others, or we have a subscription service where you can get this data sent to the cloud and get reports on a weekly basis, have a large dashboard, which I'll show you in a minute. But in addition to the 5 parameters of air quality measured by the wall-mounted sensors, which are, again, VOCs, carbon dioxide, particulates, temperature, relative humidity, this adds two additional particulate measurements. In addition to 2.5, it will measure 1 micron particles and 10 micron particles. Just to give more information, 1 micron particles are important because that's closer to the level of a viral particle. So if you saw that 1 micron particles were increasing, there is a better chance that there's, some viral particles, and we can create what's called a viral index from that as well. In addition to the 2 additional particulate sizes, this also measures ozone, it measures formaldehyde, and it measures carbon monoxide. And ozone and carbon monoxide are required by well certification for additional points. So that's one of the reasons that we added those to this that aren't available in the wall-mounted version. So this actually is a large construction company decided that they wanted to help bring people back to the office. So they wanted to show them that the air quality is good. So they have the monitors in the space, and they have a 50-inch monitor at the reception area that shows this type of data. And this is real-time data coming from the sensors. On the middle left, it shows the AQI, which is air quality index, inside the facility. And next to it, in the gold ring, it's the air quality index outside the facility. And it's not necessarily that exact. That data is taken from a local weather station. So if you happen to be in New York City on the Lower East Side, you can find a weather station on the Lower East Side. It's not going to necessarily be directly outside that building, but it'll probably be within a half a mile or so. And then it also measures the particulate levels, the CO2 and the VOCs, and puts them on the screen in real time. If you look at the lower left, it's a QR code, and somebody who walks into the facility could link to that QR code, and it gives them a lot of information. It tells them, what particle levels are, why they're, small, too many particles are bad. Same thing with VOCs. It also will tell them, the readings, if those readings that they're getting are excellent or good or fair or unhealthy. And it'll explain the readings in a little more detail than you can on a big dashboard screen like this. And then this same company, we took a screenshot during the wildfire haze that this happened to be June 8th to show the difference between the air quality inside their facility with the ionization running and MERV 13 filters, in addition to compared to outside the facility. And it's, as you can see, much better inside, similar to the engineering company I told you about in the beginning of the presentation who did something similar. Just shows that the air quality inside with a combination of filtration and ionization is much healthier than being outside when you have a haze like that. So I'll run through, this is just some testing and validation that the company has done on the technology. these are just showing the indexes of what is good, bad, or poor quality in an indoor environment. This is some of the lab testing. Um, One of the things I have to say is lab testing. If you look at any company's technology, you're going to see 90% plus reductions for all different types of contaminants. And what's important is that you do a little more research in how is what type of laboratory testing did they do? Did they go to a nationally recognized laboratory, and did they do it to a national standard? And then in addition, what's level of ionization, if it's an ion generating company, did they use? So the reason that's important is what we'll do is we use a nationally recognized company, Intertech, ETL, or Microchem. We also do it to national standard of 1053E protocol, and we generate ion levels that are achievable in an indoor space. I mean, in this case, for our testing, we generate between 800 and 1,500 ions per cubic centimeter. And we've seen other test results with companies generating 27,000 ions per cubic centimeter in their testing. And that's just not achievable in an indoor space. So just some of the homework you should do when you're looking at some of this laboratory testing. This is an eye chart, but it just shows that we do a ton of third-party real world testing in spaces. And again, I'll send this out to you, but it just shows that when you're doing baseline testing before systems turned on and then testing after, you're improving air quality in the aftermath. Just some certifications that are available with the technology, which are important. You should always have UL 2998, which is showing that it doesn't produce ozone. UL 867 is just another ozone certification. If you're doing business in California, they have a requirement for the California Air Resource Board, which is similar to UL 867. Study I mentioned earlier, this was done by ASHRAE's chapter in San Joaquin, California, where they've historically had a fair amount of wildfires, and are concerned with the particles that are coming inside of facilities as a result of wildfires. So this is the combination kind of layered effect of different technologies with MERV 13 filters that they did a study on. And they did it with PM 2.5 particulate size, a MERV 13 filter. And if you look at the far right of that chart, MERV 13 baseline was removing 93%. And then the MERV 13 plus NBI, which is the needlepoint ionization, was 93%. So the MERV 13 plus the tube-based, which is the dielectric barrier discharge, was close to 99%. And then MERV 13 with UV, 93%. It just shows, and again, this is done by ASHRAE through Fresno State University. Just shows you the combined effect of using ionization with filtration will give you a much better particle reduction in the space. And as a result, we find that people will take, when they install our system, they will reduce their MERV rating on their filters, which, as you guys know, will save energy and fan power, because the combination of the two technologies will be as good as potentially a MERV 11 and ionization could give you the ratings of a MERV 15 filter, without the pressure drop, without the cost of pushing air through the filters. Any questions? Continue on. I'm not sure if anybody, how aware you are of a new standard that came out in July. It was published in July. ASHRAE's Standard 241, the control of infectious aerosols. But I have a half dozen slides on this. Start out with the timeline. This is something that was unheard of from an ASHRAE timeline. They basically put this standard into publication in 116 days. And that was the main reason for that is it started with the White House going to ASHRAE in November of last year saying, hey, we're going to remove all the restrictions on COVID by May 11th of 2023. And we want you to come up with some standards on how we can control if we have another pandemic. So they handpicked a committee. It just so happened that our chief technology officer, Tony Abate, was handpicked to be on this committee. And the committee was chaired by Bill Bamfleth. Bill's been around giving a lot of presentations. I don't know if you've heard him. You'll get a lot more information than I'm going to tell you today. Bill was also not only the chair of this committee, he was the chair of ASHRAE's COVID task force in 20 and 21. So they put this standard out in record-breaking timing, and now they have a committee that's going to monitor and help this standard evolve over time. So a little bit about it is the first thing prerequisite is you have to meet the standard for 62.1 or 170 if you're in a healthcare facility. So you have to have the outdoor air ventilation requirements of those to start with. But this is a standard that's talking about the control of infectious aerosols. So in addition to diluting contaminants and so that they're not transmitted to people within the facility, they want a lot more ventilation or equivalency to the ventilation, what they call equivalent clean air. And for the first time, ASHRAE has mentioned bipolar ionization as a strategy or air cleaning technology that you could use to help come up with this equivalent clean air. So the purpose, again, is to minimize the risk of disease being transmitted within an occupied space. And this does a little bit more than prescriptive. It is prescriptive in the design, but it also talks about the installation. It talks about commissioning it, talks about operating and ongoing maintenance. And all these details are in a 48-page standard that you can buy at the bookstore of ASHRAE. So equivalent clean air is required if the some authority requires this infection risk mitigation mode. And what do it in an office environment right now? If you're using the ventilation rate procedure, you're requiring approximately 17 CFMs of outdoor air. With the equivalent clean air requirement, if in the infection risk mitigation mode, you're going to require 30 CFMs of equivalent clean air. In a classroom, it's going to jump from 13 CFMs to 40, 3 times the amount. And in a restaurant type of environment, it would jump from 10 CFMs to 60, 6 times the amount. So I think we're all aware that if you tried to do that with outdoor air, the cost of conditioning that outdoor air to dilute would be incredibly costly. If you try to do it just with filtration, you're going to be putting in very high MERV rated filters and costs a lot of money to push air through those filters, and you may not have the capacity with your air handlers to even increase MERV ratings on filters. And then some of the and this is all again right out of that the standard that's in the ASHRAE bookstore, but it talks about air cleaning systems that can satisfy equivalent clean air. And in addition to outdoor air ventilation, you can use mechanical filters, you can use germicidal ultraviolet, UVGI, or you can use bipolar ionization. So similar to what we did with 62.1 indoor air quality procedure to show the reduction of outdoor air in a standard time, not a infection risk mitigation mode time, but how you could reduce the outside air. We've also taken this spreadsheet calculator and done something similar with the equivalent clean air to show the contribution of bipolar ionization to the equivalent clean air. And in most cases, it will show you that an office environment or a classroom, you can reach the equivalent clean air requirements as long as you're meeting the 62.1 standard and you have technology like the bipolar ionization in addition to that. And this is all done based on testing that is required. Questions on that? Okay, so just run through a couple of case studies that just show some metrics with before and after. This happens, Empire State Realty Trust owns the Empire State Building and approximately 9 million square feet in and around New York City. And they've done a lot of testing. And matter of fact, they've done a lot of promoting of the bipolar ionization technology, and they use it as a marketing tool for every new tenant that leases space or every renewal of a lease. They install the bipolar ionization as part of that lease. Gensler, a large architect in the office environment, has put it in many of their own facilities, as well as encouraged some of their clients to put it in from both indoor healthier air reasons and also for energy cost-cutting reasons. A large facility is US Bank football stadium in Minnesota, and they put it in for three reasons. Ultimately to save energy, and then to help them with certification, well certification and LEED Platinum certification. And because this will deliver points to both of those, and I have a few slides on that later in the presentation. So all in, after about 20 months, they were close to 400,000 in savings, and they're on average they have to have they have a engineering company doing an energy audit each year, and they've got 3 years of data, and on average they're saving $217,000 a year just by between the removal of filters and the reduction in outside air. This is just a study that was done at crypto.com, formerly known as the Staples Center in LA. They did their own testing. They started out with a small luxury suite area and tested it, and then went and reduced outside air, and did some, had an industrial hygienist do the indoor air quality readings while they're in, and they saw even with the reduction of outdoor air, they were still lower in contaminant levels with the system and a reduction in outside air than without the system and full outside air. So they're saving significant dollars every year. This is a case study that was done by Guth DeConzo, an engineer out of the Albany area, for a school district, New Rochelle. It's in Westchester County in New York State. Part of the contract with between the dealer who installed this and the school was they wanted to test 10% of every space to make sure that the system was working. So they tested 97 different spaces and showed the baseline. The requirement was they had to show an improvement in ion levels inside the space. They had to show an improvement in particle levels inside the space. They had to show an improvement in VOCs and formaldehyde concentration. And there could be no ozone. It had to be within 5 parts per billion of the baseline. And it passed in every case. And this is, and as a result, they've expanded it when they added a school since then, and they're also changing their tubes. That's one of the things that, there is some maintenance associated. Every 2 years, it's recommended to change the tubes. No maintenance during that 2-year period is required, but if you change the tubes, you're going to maintain the optimal ion output from the system. And mold issues, all around the country are one of the biggest reasons that people will install a system like this, because in every case that's been tested, after the system is operating, there's literally non-detectable mold spores compared to what there would be before. And people generally, the before could be counts in the hundreds they're measured in colonies, and then after, non-detectable. So hopefully your facilities don't have that, but when they do, this is a great solution. It's not mold mitigation, meaning if it's inside the walls, the air is not getting inside walls, so it's not going to impact that, but it'll prevent mold from growing, and any surface mold that the air does touch, that will be inactivated or sterilized. Just another application at a healthcare facility in Chicago, showing bacterial reduction with the system on compared to the baseline. And similar to mold, it's basically non-detectable in a post-AtmosAir environment. So I mentioned earlier that this technology can help qualify for certain certification points. And in this case, LEED. This is based on LEED 4V1. The new version 5 that's coming out, which even has more points associated with it as far as the indoor air quality. Well, has several more opportunities. Some are preconditioned air quality that has to be accomplished, and we're working with a large facility in New York right now who's from both a LEED and a well certification standpoint, where we're helping them get all the readings, the air quality readings off their sensors, because one of the conditions is, this is not, these are not just prescriptive, they're performance related points, and they have to show 30 days of air quality within the facility within the first year and every year. And it also helps in the Fitwell certifications, and Fitwell doesn't require any from the air quality standard, just from the air monitoring. So you'll get points when you're monitoring and testing the air quality. So lastly, in addition to bipolar ionization, there's just a couple of other solutions that are offered. One is a polarized filter. We call it Biotronic. The advantage of using a filter like this is you'll get a very low pressure drop with a good particle capture rate. So, and that's done by using 24 volts of electricity going through this filter. So to give you an idea, a single you can get a 1-inch filter will be the equivalent of a MERV 11 capture or particle reduction with a MERV 8 pressure drop. And in addition, because the filters don't load just on the surface, they load through the entire density of the 1-inch filter. Then you change the filters about a fifth as often as you would a traditional media filter, again, because of the loading. So you get less pressure drop, less maintenance, and in the long run, total cost of ownership being less. And then there's also recirculating units that can be, and these are popular for odorous environments as an auxiliary system to whatever other system is in, often used in pantry areas or food kitchen areas. And these can be designed with a combination of technologies. They can have they're recirculating, and they're going to have 500 to 700 CFMs of air. That's usually good for about 1,000 square foot space. They fit in the size of 2 ceiling tiles, about 2 by 4 feet. You can have UVC in there. You can have HEPA filters. You can have bipolar ionization. Depending on what the contaminants are and what we're trying to remove, we can help you with what technology to put inside of the recirculating unit. And that's it. So now if there's any questions, happy to answer.
All right, Kevin, thanks very much. And everyone, thanks for joining. You'll be hearing from us shortly. Thanks again, Kevin.